Hi, my name is Doug Hammond. I'm going to kind of change the subject, though I think it's the same thing. I'm looking at the psychology of programming. I'm going this way because I watched someone on YouTube the other day interview a AI agent, and I'm watching this person talk to this agent and trying to change his words to the agent so it gave the response this guy wanted to get. And I'm going, this is kind of crazy. 25 years ago, 2020, 2000, I bought this. The psychology of computer programming by Gerald Weinberg. And I remember briefly looking at it, and I want to read a relatively short comment he has here on personality factors while programming. And it's a very short thing. He says, were I writing the psychology of computer programming from scratch today, this chapter that he just went through, chapter 8 in the book, would change the most. For this is where I have learned the most in the past 25 years. First of all, Isabel Briggs Myers published her MBTI in 1980. Causing me to drop all other personality testing theories as of slight relevance to programming.
That's the Myers-Briggs.
Myers-Briggs. Dr. Ting talked about this. And this was before I knew about it when Ting talked about it, but I figured, gee, that was interesting. Then in 1984, David Kiersey and Marilyn Bates published their related theory of temperament. Carl Jung did the types. Kiersey and this gal, Marilyn Bates, did temperament, which is slightly different. But they used the same code, four-letter code, in which, like the MBTI deals with normal personality differences. And that's, I'm going to stop here. What is normal? There is no normal. But when you have AI, you're going to have this convoluted computer normal. And so you go, uh-oh, I got to learn more about artificial. That's what it sounds like to me. And I and others have since explored this approach to personality in the context of the software business. And in particular, he has a book on quality software management, how to develop quality software, taking into account human personality of the problem in the programmers. During the same period, I studied with Virginia Satir, learning about incongruent personality stances, ways of coping when stress goes beyond the normal range. And Virginia Satir is like a counselor or a therapist that helps you understand or helps you become aware of when you get caught. All of a sudden, you're in a loop, not working right, to recognize it and take whatever appropriate measures you have learned over the years, and maybe look for nuances. And to try to help you move to the other space. Like with Chuck, with the color forth all of a sudden not working right, after all this time with Windows 10 and 11, whatever, okay, what's needed is something from the outside to look at Chuck and the problem of the computer. What the answer is, I have no clue, but it just says, oh, we need to do something different. In the first edition of this book, I predicted attention to the subject or personality should make substantial contributions to increase programmer performance, whether that attention is paid by a psychological researcher, a manager, or the programmer himself. Even though I knew next to nothing about finality of time, this turned out to be one of the most successful productions. And in it, they talk about a book called Gifts Differing, and of course, Please Understand Me, and some Virginia Satir stuff. But the whole point is, what I look at trying to solve problems requires a lot of things. When I began to look at language, the linguistics of language, I realized that's a really how does our brain begin to understand language, whether it's spoken or written program. And so all I'm inviting everyone to do is to take a little time. There's some books that this series of books I've never seen. It says problem solving principles for programmers. Then they have it in BASIC, same thing. Then they have it in Pascal. So it's the same identical book, just rewritten slightly for the language that you're playing with. And I found that very powerful, and something so simple as the number of programmers, what happens to the number of, when you have a whole bunch of programmers in a project, or a whole bunch of people in a project. Pretty soon you begin to find out, gee, I don't need everybody, or I don't need to interact with everybody. And when you have like people that you're going to have a quick meeting with to talk about the code, or talk about, the project, whatever it is, or anything else really, it's just the idea that there's sort of an optimal number of people to play around with for the given time that you've got. So that says, okay, fourth is about optimizing. Fourth is about minimizing, making it so that it's the most of with the least. And this, looking at simple math, it's called the binomial coefficient formula. That says if you got, 8 people in a project together, there's actually 28 relationships between 8 people. And so if everyone takes just a minute, and you have a 60-minute, meeting you're going to put together, if everybody exercises that 1 minute, you've only got 32 minutes for the meeting. Most of the humans get together and we want to chit chat about something or whatever, or distracted. So the whole idea, it's the whole environment, both the machine, the language, and yourself. And the real issue is I remember when I first heard about computer language, I didn't know, I almost got afraid. Which language should I learn? Because if I learn that, that's going to screw my mind. It'll screw my mind up for the others.
This meeting is being recorded.
And so the whole idea is ultimately we need to look at us programmers or us thinkers. And so, because I remember last year I asked, have you found if you speak a foreign language, has that helped you or hurt you while programming? So in a similar sense, I'm asking you, as you use AI or you get involved with AI, is what you've learned in all your programming, or in fourth in particular, is that helping you or making things cloudy? And I don't know the answer, and that's what I wanted to do. Just ask you guys to be aware of the human interface. And that's it. Now, what I'm asking, have any of you noticed that when you're working with something that is, well, actually, when you were showing Sam, I think it was, how complex it got. I started thinking, gee, then when you showed it in a slightly, more organized thing, well, what if we can be writing code that went in and looked at what's going on inside the system and try to show us in some graphic manner or some other manner the trouble we may be heading toward. You know, I know this is strictly hypothetical, but the idea is how can we operate differently now that the artificial AI is replacing kind of the artificial application we're creating that, you know, artificially tries to do something for it that's real. I'm not sure if I'm getting across on that, but there's so much virtual stuff going on that sometimes I'm trying to get back to a sense of reality quickly so that you're helped, not hurt. And I think studying linguistics, how language are and used could be helpful. So that's the basic part of it. So any questions or thoughts?
Why don't you press the doorbell?
Oh,
Oh, sorry. That's all right. Alright, so next up,
I can't quite tell if that was a very muffled introduction or not. Could you please confirm Stamford Room?
Hey, Black, you're up.
Okay, I hear it. I hear